So we're going to try these questions. Start with very basic ones. Okay. All right. Let's start with the first question. It's very easy here. You guys already know this stuff, right? This one is x to the power of 2 plus 5 plus 3, so that's equal to 10. Oh no, yeah, 2 plus 5 plus 3 is 10, so x to the power of 10 there. This one is the same as x to the power of 3, y to the power of 3, so these are just warm-up questions, as you can see. Y to the power of 5, so this is equal to x to the power of 7. You need to add these indices, and then y to the power of 8, okay? This one here is very simple as well. So m to the power of 5, p to the power of 5. This one here, you got to square that. So 2 to the power of 2, 2 to the power of 4, x to the power of 4 to the power of 2. So that's 4x8. This one is 4 to the power of 5, whatever that is. This is x to the power of 2 to the power of 5. In that case, you need to multiply, right? Not add them. So this is equal to 4 to the power of 6, because there's another 4 there, and x to the power of 18. Okay, so that's clear enough. Let me know if there's any question. Now, if it comes to division, you can write it as a to the power of 7, b to the power of 8, over, because it's divided, a2, b5, and just need to subtract them. So you get a5 and b3. Let's move on to b here. So at the moment it's pretty easy, but it gets harder. Just wait for it. So that one divided by this. So that's equal to, so 2 to the power of 3 is 8, a to the power of 3, b to the power of 4. So this one is 2 divided by 2 and 8, that becomes 4 on the bottom because there's 8 there on the bottom. And you get a9 and then b5. So I hope that makes sense to everyone. Let's keep going. So there is really no need for any bracket there because there's no square. It's just equal to 3x5 y11 over 6x squared y2. So this is equal to 2 here because 3 and 3 cancels out. You get x to the power of 3, y to the power of 9. This one here, p13 q10 over p squared q8. So it's p11. All of these cancel, you know, because 8, that's lower than 10, 13, that's higher than 2. That's the reason. So that's the answer, p11 q2. Let's move on to this one. This one is 6 times by 9, which is 54. W6, because W2, W4, T7, T7, 12. So that's T19, right? Over. This is 3 to the power of 5, W5, T13. Okay, so let's calculate what 54 over 3 to the power of 5 is. So 3 to the power of 5 is 243, so 54 over 243 simplifies down to 2 over 9. So these numbers simplify down 2 over 9. So that's 2 there and 9 there. W6, W5, so you get 1 W on the top. T19, T13, so you get T6 on the top. Okay. Moving on to the next one. That's 16 I'm going to just leave it as 2 to the power 4. But I think 16 is simple enough. So 16 x to the power 4 y times by 9. This one is x to the power 14, right? And then y square. Okay. Next, it's 18 x to the power 5. 2 to the power 3 is 8. And then y to the power of 3. So things like this, they are easy, but if you don't have enough practice on them, it's very easy to get things wrong. I'm just going to use calculator for all these numbers. So 16 times by 9, divide that by, so 144, divide that by 18 times by 8. This calculator simplifies that for you. So it's 1. So that means all these numbers cancel out. You get x to the power of 18, y to the power of 3, and x to the power of 5, y to the power of 3. So this cancels out. You get x to the power of 13. That's the answer. Now let's go through this one. You're going to actually copy that. So this one here is 15a8 b3. So you can actually first simplify this one first if you want. So divide both sides by 3, 3, 3. Then you get 5 over 3. And then this is a A4 on the top. But it's B5, B3, so you need to have B squared on the bottom. And then it's divided by, but anyway, division can be converted into multiplication, and you can simply flip these two. So it's a 2a cubed b, and then 3ab square, square. So this square still applies. You can simply flip the fraction. So this is equal to 5 over 3a to the power of 4b squared times by, this is equal to 9. Oh, we can actually, before we square, we can actually simplify this. So it doesn't matter, you can square first and then simplify. But it's a 3, 2, so a, 8, 3, so a squared on the bottom, b squared b, so just one b on the top, and then squared, right? So it's 5a4, 3b2, times by 9b squared, 4a4. Okay, square, 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 square. Then you can do some calculation. B squared cancel out. A4 cancel out. So it is going to be 3 and 9 cancel out. So that's 1 and 3. So that'll be 15 on 4. 15 on 4. Let me double check. Question 4a. Question 4a is actually 15. I think I missed something here. Can you guys see where I made mistake? The answer could be wrong. I don't know. Not all these answers are correct, you know. Nepo and Valerie, do you guys follow this pretty well?
You do it a little bit differently from how I do it. Like it's like the same concept, but I write it out a little bit differently. So
okay, but if you think your method is efficient enough, that's fine. You can stick to that.
all right.
But it doesn't hurt to. But in when you go to year 11, you need to know how to do things in many different ways. So yeah, it wouldn't hurt to learn my method over here.
Yeah.
Yeah. So did you get the same answer, by the way, 15 on 4?
I don't know. I was just trying to follow along with this.
Okay.
Yeah.
I'm not sure if I made any mistakes. So in terms of numbers, because all the coefficients cancel out, let me just do calculation again. So just taking the 15 on 4, 15 on 4, divide by bracket, just a 2 on 3. If these are all the numbers in the square, it is going to be 5, that's 5, 3, that's 9, 4. Oh, sorry, this is 15 on 9, sorry. 15 on 9 here. It is 15 on 4. So 15 on 4 should be correct. Okay. Yeah, so I'm going to leave these questions as homework. So you need to submit this answer to me by tonight or tomorrow night if you have time. We're going to try 7a now. So it says write in the simplest index notation and evaluate. Well, this is 2 to the power of, let's try 7a. So that's 2 to the power of 4. 4 is 2 squared, isn't it? Squared. That's what 4 square is. 8 is the same as 2 to the power of 3. So this is 2 to the power of 4, 2 to the power of 4. This is 2 times by 2, and 2 to the power of 3. So this is 2 to the power of 11. You add them up. So remember this rule. If you have a to the power of b, a to the power of m times by a to the power of n, you need to add them up, right? M plus n. If you have a to the power of m to the power of n, that's a to the power of m times by n. Okay, so these are all reducible in terms of 3. Maybe this one is in terms of 2s and 5s. So you can see that 20 is 2 times by 2 times by 2 times by 5. So it's 2 squared 5. That's what 20 is. 8 is the same as 2 to the power of 3. This one's to the power of 4. 125 is 5 to the power of 3. 5 times 5 times 5 is 125. So this is equal to 2 to the power of 10. 2 times by 5. 5 to the power of 5. Times by 5 to the power of 5. And then 2 to the power of 12. 5 to the power of 3. So this equals to 2 to the power of 22. 5 to the power of 8. So that's the simplest form. I'll leave these questions to you as homework. So try that tonight. So the circled ones. We tried all of this here, so there's no homework for that. We're going to try question 8a. So write this in the simplest notation and evaluate. Well, this one is very simple. This one is 2 to the power of 2 to the power of 5, isn't it? So this is 2 to the power of 10. That's the same as 4 to the power of 5 there. This is 2 to the power of 7. So this must be 2 to the power of 3, which is equal to 8. So you don't need any calculator. So the less you rely on the calculator, the better results you'll get. So it's actually, it's an irony, isn't it? So a lot of people think that if you rely on calculator more, you get better score. But but it works the other way. If you use more of your numerical skill and rely less on calculator, you get better score. This one here is 3 to the power of 3 to the power of 4. So 3 to the power of 2 to the power of 4, because 9 is 3 to the power of 2. So this is 3 to the power of 8. This is 3 to the power of 5, divided by 3 to the power of 3. because 27 is 3 to the power of 3. So that's 3 to the power of 13 divided by 3. So this is 3 to the power of 13 minus 3 is 10. So that's the answer. So you can try these questions yourself without, try doing this without any calculator. Okay, but if you don't know what 27 is, okay, what we do is we divide them into prime numbers. So 2 is a prime number, 3 is a prime number, like 5 is a prime number, right? But if you have 6, 6 is made up of 2 and 3. So try dividing 27 by 2, it doesn't work. So divided by 3, divide by 3, divide by 3. So that means we know that 27 is made up of 3 to the power of 3. Let me talk a little bit about like 100, let's say 112. How do you simplify that into indices? Take 112, you can use calculator in this case, divide by 2, divide by 2, divide by 2, and divide by 2 until you can't divide by 2. So how many times did I do that? I think I did it by 5 times or something. No, 4 times. Yeah, 4 times. So this is made up of 2 to the power of 4 times by 7. 7 is also a prime number, right? So this process is known as prime factorization. Maybe you guys have heard of this already, right? If you have like 150, let's say 6, you can also do the same thing. Divide by 2, then you get 78, right? Is that right? 78? Yeah. 75, yeah, 78, that's right. So you divide this into 2 again, then you get 39, true? So 156 is made up of this, and this is a prime number, so you can't divide, you can divide this by 3. So 3 and 13, so it's made up of this and this and this, 4 of these. So 2 by 2 by 3 by 13. That's 156, right? Now, I'm going to move on to question 9. So look at this, question 9. So what I'm going to do, maybe D and E for you, and you can try B, A, B, C yourself. So D. So these are all really complicated looking, but you have to get it down to 2 and 3 and 5 and 7, all the prime numbers. So 12 is made up of 2 times by 2 times by 3, isn't it? So 12 is the same as 2 squared times by 3 to the power of n minus 3. 27 is the same as 3, 3, 3, so it's 3 to the power of 3 to the power of 1 minus n. Divide. This is a 3 squared 2n. 8 is 2 to the power of 3 to the power of n minus 1. 16 is 2 to the power of 4. 2 times 2 times 2 times 2 is 16. So you got it down to in terms of 2 and 3s. So now this is equal to 2 to the power of 2 times by n minus 3. 3 to the power of n minus 3. And then 3 to the power of 3 times by 1 minus n. Next one is 3 to the power of 4n. 2 to the power of 3 n minus 1. 2 to the power of 4n. And then you take care of the 3s and 2s. So let's deal with 3's first. So this is basically n minus 3 plus 3, 1 minus n. So add these two and then subtract 4n. So we don't know what they are, so we just have to add these two because they're on the numerator. This is on the denominator, so subtract. So this gives us n minus 3 plus 3 minus 3n minus 4n. That leads to these to cancel. Negative 3 plus 3. This is a negative 2n. So it's negative 6n. So you can write, you don't need any fraction because it's going to be just, we don't know which one is bigger, whether that bit is bigger or this bit is bigger. So you just need to do that minus that. And it gives you 2 to the power of negative 6n. And do the 3. So, sorry, this is actually 3 here. We do 2. I want you guys to try this one and let me know. So Nepo and Valerie. So you guys see what I've done here, right? So you got to do that minus this minus this. So once you finish, you can type your answer on our group chat.
Sorry, what are we doing?
So we're trying to figure out this, we're trying to simplify this one into something like this here.
Okay.
So we simplified 3 to the power of this, 3 to the power of that over 3 to the power of 4n into 3 to the power of 6n, negative 6n. The reason is you have these two, so you add them, and you have this guy, so you subtract. So you get negative 6n, right? So what you have to do is figure out, you got 2n minus 3, which is this one here, and then you will have to subtract n minus 1, 3n minus 1, and subtract 4n as well. So you need to work this one out. So who's finished? So if you've got something like that, it's 2 to the power of 2. If you have 2 to the power of 3 over 2 to the power of 5, there are two ways of doing this. If you use the same method, 5 minus 3, get 2. So if you do 3 minus 5, that's negative 2, isn't it? So you can just get rid of the fraction and just write it as this. 3 minus 5 is negative 2. Or you can just keep the fraction. Instead of doing 3 minus 5, you can do 5 minus 3, because 5 minus 3 is positive. And you can have the fraction, so this one disappears, and you have 2. So you need to know that this one is actually the same as this one. 2 to the power of negative 2 is the same as 1 on 2 squared. So there are two ways. If this is greater than this one, you can do that minus that and keep the number on the denominator. Or if you can do simply just that minus that, and whatever the result is, you can just have 2 to the power of that result. So in this case as well, 3 minus 5 is negative 2. So you can just do 2 to the power of negative 2. So in this case, we're actually using this first method here. Like for example, we don't know whether that's bigger number than this one, right? So we simply get rid of the fraction and simply do that plus that minus that. And we just have 3 and no more fraction. So in a similar way, you can do that minus that minus that, okay? And just have 2. And whatever the result here is going to be that one there. So this is equal to 2n minus 6 minus 3n plus 3 minus 4n. Just expand it all out. Now, this is 2n here, 3n, 4n. So that's negative 7n plus 2, so that's equal to negative 5n. And this one is negative 3. So this is equal to negative 5n minus 3. So what we notice is that there's negative sign on everywhere, right? So you can actually make this into 1 over 3 to the power of, just make that positive. And also just take positive, negative value of that, which means that you make that positive, positive. And this becomes 5n plus 3. So that's alternative answer. If you don't want any negative sign, you can do it that way. Okay. So the reason for that is because if you have 3 to the power of minus x, this is the same thing as, let me actually go through this one with you. So if you have 2 to the power of 3, that's 8, right? 2 to the power of 2 is 4. 2 to the power of 1 is 2. And 2 to the power of 0, can you guys guess what 2 to the power of 0 is? Anyone?
0.
It is 1.
Oh, right.
Sorry,
Yeah.
but it's 1. So the reason is you're dividing it by 2, dividing it by 2, dividing it by 2, okay? So this pattern continues. So if you divide 2 by 2, you get 1, right? So if this pattern continues on, so what's going to be 2 to the power of negative 1? Two to the power of 3, or 2 to the power of 1, to the power of 0, to the power of negative 1. So it'll be, you divide by 2 again. Understand? So that'll be 1 on 2. What will be 2 to the power of negative 2? It'll be 1 over, if we divide this by 2 again, it'll be 1/4. Okay? So, but 1/4 is the same as 1 over 2 squared. Do you notice something? 2 to the power of negative 2 is the same as 1 over 2 squared. 2 to the power of negative 2 is 1 over 2 squared. So if you have 2 to the power of negative 6, that'll be the same as 1 over 2 to the power of 6. All right. So in a similar way, if you have a 3 to the power of negative 6, you can make that into 1 over 3 to the power of 6n. If you have 2 to the power of negative 5 minus 3n, you can see that 2 to the power of minus 5 plus minus 3n is the same as 5n plus 3 with a bracket there. So you can change that to 1 over 2 to the power of, so whatever is this number, so it goes over here. So this number goes over here. So that's a 5n plus 3. Okay. So that's the, so anyway, we just did D there. We can try E as well. We can try E together. So I think this will be made up of 2s and 7s. Let's try that now. So it's 2 to the power of 2 to the power of n, 7 to the power of n minus 3, 7 square 3n plus 1 over 14 is the same as 2 times by 7 to the power of n plus 2. So this one is 2 to the power of 2n, 7 to the power of n minus 3, 7 to the power of 6n plus 2, because you times it, times by this, times by this. Or you can, if you don't want to skip any step, you can just do a bracket, 2 bracket, 3n plus 1. This one is 2 to the power of n plus 2, 2 to the power of that, and 7 to the power of n plus 2. So here you can do this one, and these ones here. So it'll be 2 to the power of 2n minus n plus 2, 2n minus n plus 2. So I want you guys to try that now. What's 2n minus n plus 2? So I want to subtract this from this. Try that now, let me know. And the other one is n minus 3, 2, 3n plus 1, and n plus 2. So that thing is here. You can do all of that. So if you do the second one, that plus that minus this, you get something like this. And you can see that this one here is n, 6n, negative n. So n and n cancels out, I get 6n. That's negative n, positive n. This one is negative 3, positive 2, negative 2, negative 2, positive 2 cancel out. You get negative 3. So you get 6n minus 3 for that. So the first one was n minus 2. Second one is 6n minus 3. So I don't think that's too bad, you know. So make sure you try this yourself. Okay. We're going to move on to the next question. Now, we're going to move on to negative powers. Okay. So let's scroll down to this one. Yeah, we kind of covered the negative indices already. So if you have a negative index, you can simply flip it, send it to the denominator. So that's the answer. This one here is the same as that. This one here, you can simply flip the so this case here, this was it was on the numerator, it went to the denominator, right? So this one can be changed to 5/3. Simply swap the fraction, numerator with denominator, and then have positive index. So this is the same as 25/9. Next one, you can also change this to 4/7 to the power of 5. So that's equal to 4 to the power of 5, 7 to the power of 5. This one here, you can change it to 9/1, which is 9 to the power of 2. So this is 81. This one, on the other hand, there are a number of ways of doing this. First, you can make it into 1/64 square. That's what this bit is. 1/64 square to the power of 3, which makes it having 1/64. 2 to the power of 3 is, power of 2 to the power of 3, that's power of 6. So you can have that. Or we can simply multiply this out and have -2 times by 3 is -6, right? You can have that first and then convert that into this one. Okay. Now, as for this one, it's a little bit confusing. You need to think that this is -1 there, so you can simply move this down to the denominator. This whole thing goes to the denominator and power 1, positive 1. The reason is, if you have like 3 to the power of -1, that's 1/3 to the power of 1, right? If you have a to the power of -1, it's 1/8 to the power of 1. So if you have some bracket to the power of -1, that's 1 over this bracket to the power of 1. So if that's -3 in here, this negative still goes to the denominator like this. So that's what we're doing here. And this is same with the power of 1 is same as just nothing, you know. So this is equal to 1/3, but usually we place this negative sign on the top like that, or at the front, like so. We're going to move on to the next question. So you can simply flip the fraction into 2 to the power of 3 and 3 to the power of 4 and to the power of 4. Okay? And then this is 2 to the power of 3 times by 4, which is 12, over 3 to the power of 16. So you can leave your answer like that. Next, we're going to try these questions here. Okay, so this one is 2 to the power of 3 but this negative sign. Now, one thing that I need to tell you is if you have -2 to the power of 4, that's -2 times -2 times -2 times -2. So if you have even number of negative signs, that's positive. So this is positive 16. If you have -2 to the power of odd number, then what happens is this negative sign survives. So in a similar way, when you have a bracket to the power of 3, this is the same as negative 2 to the power of 3. Understand? So they're very different, though, the way you write this one. So, negative 2 to the power of 4, this one is not going to be negative 2 to the power of 4. That's actually wrong. This has to become positive. So this is the same as this one here. So 2 to the power of 3 with a negative sign there, so put a negative sign because it's odd power. And 2 to the power of negative 4 simply can go to the bottom, 2 to the power of 4. So this one can go down because it's negative power. And this is negative power as well, so this one can go up as positive power. So this is positive 2 to the power of 6 there over 2 to the power of 4. So this is a 2 to the power of 2. 6 minus 4 is 2, right? With a negative sign. So that's the answer for this one here. Next, I'm going to copy this one. So there are a lot of things you can learn from this exercise. So this one here is, so you got negative index there, right? But does that mean it can go to the bottom? Not really, because it's actually protected by power of 3 there, right? So you cannot simply move this thing. So if you want to move this thing down because it's negative power, it still must be within the same numerator because it is protected by this. There's another layer with 3 there. So this is making things a lot more complicated, right? But because its negative index is on the outside, this one can simply migrate to the bottom like this, but not this one here. Okay, so rather it's better to, so I hope that's clear. Maybe it's getting a bit too complicated, but you definitely need to understand all of this that I'm explaining here. So you can just multiply this out, then you get this, right? And then multiply this out. It's a lot simpler if you just multiply this out. You get negative 8. And they get x to the power of negative 5. And this is y to the power of negative 6. And what happens is this one and this one go down. This one and this one can go up. So this is x to the power of 5, x to the power of 6, y to the power of 6, y to the power of 8, times. So this is 1, because these cancel out, they get that smaller. So it's going to be x, y squared. Okay, so hope that's clear. Let me just connect my laptop to charger. It's running out of battery. Okay, so I hope that's all clear. So that's all covered. You can try this as homework. Now we're going to try number 3. So it's actually cut short a little bit. So we're going to now talk about fractional index. So you can do things like this without any calculator. So I'll show you something. So if you have 8 to the power of, let's say a to the power of p over q, this is the same as the qth root of a to the power of p, or it's the qth root of a to the power of p inside. So that doesn't really matter which way you do it. So, but this is a lot easier rather than this one. So I'm going to show you. So 8 to the power of 2 and 3. That's the same as cubic root of 8 and then square, or cubic root of 8 square. So cubic root of 8 is 2 because 2 times by 2 times by 2 is 8. So therefore cubic root of 8 is 2. If you have 2 times by 2 is 4. If you simply the square root of 4, then you get 2, right? So anyway, this is 2 to the power of 2, so this is 4. You can do it this way as well. So this is cubic root of 64. We know that 4 times 4 times 4 is 64, so this is 4 as well. All right. So this one here is quatic root of 81 to the power of 3. But 3 by 3 by 3 by 3 is 81, so this is 3 to the power of 3, which is 27. This one is cubic root of 125 to the power of 4. 5 by 5 by 5 is 125, so this is 5 to the power of 4. And this one here is, you can apply the 8 to the power of 1 on 3, 125 to the power of 1 on 3. So this is equal to 2 over 5, because 2 by 2 by 2 is 8. So you need to know that 1 on 3, that's the same as just cubic root. So one thing that you need to know is that a to the power of 1 on n is the same as nth root of a. So that's very, very important. Moving on to next. So I'm going to give a couple of, let's try a couple of questions here. So the goal of this is to simplify these with the positive indices. So I'm going to go with I here, okay? So this is the same as x to the power of 3 on 4, that's that bit there, to the power of 2 on 3, times this one here, which is x to the power of 4 on 3, to the power of 3 on 8. You times them, so it's x to the power of 1 on 2, x to the power of, so that's a 3 cancels out, it's also 1 on 2. That's x to the power of half plus half, which is 1. So the answer is just x for that. Okay. So you can try, can you guys tell me which question you'd like to try here? Valerie? Which one looks interesting?
H.
H? Did you say H?
Yep.
Okay. So this one is 3 to the power of 3 to the power of negative quarter, right? 9 is 3 squared to the power of 2 and 3. 3 to the power of negative 5 and 4. So this is equal to, let me just write it here, 3 to the power of negative 3 on 4, because it's 3 times 1 negative quarter. And then 3 to the power of 4 on 3. 4 on 3. Negative 5 on 4. Okay. So you get, this is equal to 3 to the power of that plus that plus that. So it's a bit challenging to add them all up because they're not in the same fraction denominator. So you need to make that in terms of 12. So times it by 3 and 3, so you get negative 9 on 12. Plus, times it by 4, you get 16 on 12. Add this one, which is 15 on 12. So that's 3 to the power of negative 24, negative 8 on 12. So that's equal to negative 2 on 3. You're supposed to make this one into positive index, so therefore you have to do this one. Okay. So that's the answer. I guess we can call it a day here. So you can try all of these as homework. Let me know if you struggle with any of those. I'll provide some solution for them. Okay. So I hope this is not too challenging for you guys. Yeah, it's a necessary step before you guys go into your lab. All right, we'll call it a day here.
See ya.
See ya.